Let us continue with the application of derivative in finding now the length of a plane curve. So now let me give you first the formula. If y is equal to fx, that means if y is a function of x, then the length of the given curve from x is equal to x1 to x is equal to x2 will be given by the formula s is equal to integral x1 to x2 square root of 1 plus dy dx the whole square dx. So first step from this given equation, you differentiate y with respect to x. Then after that you substitute it in this formula and see what will be the value of x1 and x2 and integrate it from x1 to x2. However, if x is a function of y, then in that case, what we need to do is we need to differentiate x with respect to y. So the formula in this case will be integral y1 to y2 square root of 1 plus dx dy the whole square into dy. And if the given equation of the curve is given in terms of parametric form, that is x in terms of t, y is a function of t, then the length of the plane curve from t is equal to t1 to t is equal to t2 is given by s is equal to integral t1 to t2 square root dx dt the whole square plus dy dt the whole square dt. Now let us apply these formulas in finding the length of the given curve. So the first one is find the length of the arc of the parabola y square is equal to 4ax measured from the vertex to one of the extremity of the lattice rectum. Since we have done in the second semester, we have discussed thoroughly regarding the equation of the parabola. Now this is the parabola whose vertex is the origin 0, 0. And lattice rectum is nothing but it is a straight line which passes through the center, through the focus S having the coordinate a 0. Now we have to measure the length of this one from here to here. Now here x is equal to 0 at this point, and at S the value of x is equal to a because it is perpendicular to the lattice rectum, perpendicular to the x-axis and passes through the focus. So in this case, x1 will be 0 and x2 will be a. So let us find out what will be the equation of, what will be the length of this one. So first step, what we need to do is, from the given equation y square is equal to 4ax, we can find out what is dy dx. So on finding dy dx, we get it as 4a by 2y. 2 and 4 can be cancelled, so we'll get 2a by y, or dy dx is equal to what? Now in place of this y, you can find out what is a positive square root of this one. It will be 2 times of a square root of 2ax. 2 times of square root of ax. So finally we'll get dy dx is equal to square root of a by x. Now knowing the value of dy dx, then we can find out what will be the required length. Since here it is from the vertex to the lattice rectum, so x1 will be 0 and x2 will be a. So into square root of 1 plus dy dx the whole square dx. Substitute the value of dy dx, then you'll get it as square root of 1 plus a by x dx. Simplify this one, and on simplifying this one, we'll get it as integral 0 to a half of 2x plus a by 2 dx. You can simplify this one, then you'll get the original one, x plus a only in the numerator. Now you can consider this one. It will be half integral 0 to a 2x plus a by square root x square plus ax dx plus a by 2 integral 0 to a dx by square root of x square plus ax. Now the first one is, see, the numerator is the differentiation of the term inside the square sign, that is d of x square plus ax. So it will be of the form du by square root of u. So in applying that formula, then you will get the integral of this will be 2 times of square root of x square plus 4a plus ax from 0 to a plus a by 2 integral 0 to a dx by square root. Again here this one, x square root of x square plus ax, you can simplify it by adding and subtract by a by 2. Then you'll get square root of x plus a by 2 the whole square minus a square by 2. So this is a standard integral. It is equal to log of x plus a by 2 plus square root of x square plus ax from 0 to a. So on substituting the limit of integration, then finally you'll get it as square root of 2 into a plus a by 2 log 3 plus 2 root a. So this is the way of finding the length of the given curve from the from x1 to x2. Now let us come to the next one, which is application of that parametric form. Find the length of the arc of the curve x is equal to t square, y is equal to t cube from t is equal to 0 to t is equal to 4. Now for this one, the length of the given curve is given by the third formula. S is equal to integral 0 to 4 square root of dx dt the whole square plus dy dt the whole square dt. So on substituting the value of dx dt, you can differentiate this dx dt here. It will be 2t and it will be 2t, and then what is dy dt? Dy dt it will be 3t square. Substitute it here, then you get square root of 4t square plus 9t to the power 4 dt. T is common, so you'll get integral 0 to 4t into square root of 4 plus 9t square dt. Now let us substitute this term here, 9t square plus 4 by u square. So differentiate this one, you'll get 18t dt is equal to twice u du, or 9t dt is equal to u du, which will implies that t dt is equal to u by 9 dt or du. When t is equal to 0, because the initial value of t is 0. So when t is equal to 0, let us substitute it here. Then u square will become 4. We'll take only the positive square root. U is equal to 2. When t is equal to 4, substitute the value of t. Then you get u square is 148. And this will imply that u is equal to this one. So substitute it here, and then by method of substitution, we can easily find out the length of the given curve. X is equal to t square, y is equal to t cube, from t 0 to t is equal to 4, which is 8 by 27, 37 root 37 minus 1. Now let us discuss one more problem. Find the perimeter of the circle x square plus y square is equal to a square. Now perimeter of the circle, we know that for a circle x square plus y square is having a radius r, the perimeter is given by the formula twice pi r. That one you have done, I think, right from school days. You know what is the perimeter of circle. It is twice pi r, where r represents the radius. So here we have to show that the perimeter of the circle by using integration as twice pi a, because a is the radius. So from this given equation, we can find out dy dx. That is, differentiate this equation with respect to x. Then you'll get dy dx is minus x by square root of a square minus x square. Now it's enough for us to find, because here you see that the center is the origin and the radius is a. So the length from here to here is from x is equal to 0 to x is equal to a. So it's enough for us to find only the length of this one, and then because the length of this is same as this one, same as this one, and same as this, so we can multiply it by 4. So the required perimeter is equal to, why I'm writing here as 4, because I'm taking only that arc which lies in the first quadrant. So by taking all, the perimeter means this one surrounding of the circle, the length of the surrounding of the circle. So I have to multiply it by 4 times now. 0 to a square root of 1 plus dy dx the whole square dx. And this is called 4 integral 0 to a, substitute at dy dx. And then on simplifying this one, you'll get 4a integral 0 to a dx by square root of a square minus x square. And this is a standard integral, which is sine inverse of x by a from 0 to a. So on substituting the value of this limit of integration, you'll get it as 4a into pi by 2 minus 0, which comes out to be twice pi a, the circumference of the circle. So hope now it's clear that how to find the length of the plane curve using method of integration.